Hello, and welcome to Proof of Talk, the cryptocurrency podcast where we invite leaders and builders into the space to come on and talk about their experience in the industry, as well as the projects and products that they've been building. My name is Andre, and I've been in the cryptocurrency space since 2017. I've also helped co-found algorithmic crypto trading platform Acier that enables users to quickly and easily automate their trades while managing the risk. Hello, everyone, and welcome to Proof of Talk. I'm your host, Andre, and I'm here today with Dean, who's the CEO of Agoric. Nice to meet you, Dean, and thanks a lot for accepting my invitation. How are you doing?
Thank you so much for having me. I'm doing very well. It's great to be here, Andre.
Fantastic. Well, listen, let me just start and ask you, how did you first get into crypto? It's a question I like to ask my guests, and I always get a different answer, and it's kind of a fun one.
So, depends what you mean by crypto. You know,
Blockchain, like blockchain tech.
oh, because I was going to say, I think in 83 or 84, I discovered, I saw the RSA description and then was talking about it with people at Park and, and where would this go? And, and then and grew into cypherpunks and so that's how I got into crypto. But
Like OG cryptography, right?
blockchain. So 2017, there were, so I knew people that were kind of, interested in Bitcoin, and Bitcoin to me was being sold sort of totally the wrong way because it was being represented as sort of the perfect cryptocurrency. And having worked with CyberCash and DigiCash and all these things that had, fast finality, anonymity, untraceability, all these things that you would like in a cash, or Bitcoin had none of those. And so, but people who didn't understand it were misrepresenting it. And you look at sort of the bad software was built on, and it really looked like a fly by net kind of operation. And so, so I wasn't very involved in the early blockchain space. We had lots of conversations and lots of work on smart contracts before then, right? I worked on the first production smart contract in 1989, and they really do require blockchain, right? Smart contract, pre-blockchain with us and with Nixabo and others is, software that's enforcing the terms of a contract-like arrangement between third parties. So, $1 trillion market cap before blockchain with Airbnb, Uber, Lyft, eBay, PayPal, Venmo, all these are smart contract businesses enabled by the internet. And that was always fascinating to me, right? So ETH came out, and that was interesting because it was, the thing that Nick had been talking about, a lot of sort of autonomous programs that could operate as smart contracts, that could help, other people do things. But it had these clear sort of fundamental architectural security flaws, that we saw in ActionScript of Flash, right? And it's the reason why, or a big reason why Flash is no longer around. It's just, synchronous reentrancy and the security model are just things that humans can't do software at scale with, and can't do complex software, can't do very well. And that's borne out with the losses people have gotten in even relatively, I mean, important and valuable and big piles of money, but the programs are fairly simple, right? So 2017, there were all these breaches. We had done a bunch of, Mark Miller and myself and a few others had done lots of smart contract work prior to this, smart contract work at Sun Microsystems and helping, distributed e-commerce and all this sort of stuff that are all smart contract blockchain. And Zuko of Zcash, founder of Zcash, Zuko Wilcox, knew that we had done this, right? We worked with him on zero knowledge stuff in some of his earlier projects, and knew that we had, been working on this stuff for a while. And so he connected us. He brought in and helped, get a panel together, like had Zuko, it had Jorge Lopez of a project called Gravity back then, who he really internalized our model and and how it could relate to blockchain. Brian Warner, who's our lead crypto guy now, who at the time was on Least Authorities or had done Least Authorities security audit, right? Or was one of the people on the security audit that identified the reentrancy issues for Ethereum. And Arthur Brightman of Tezos, where the coincidence this panel ended up happening right when Tezos was having its fundraise, its ICO. And so from the beginning of the panel to the end of the panel, Arthur is there talking about, the agoric model, if you will, of how to do large scale distributed smart contracts versus and how
Right.
it relates to sort of blockchain technology and what blockchain can do. And sort of from the beginning of that to the end of that, his network value went up by $20 million or something, right? So it's just that was the panel, and the outcome was yes, that approach to how you do smart contracts looks like it is very different than what we're currently doing. Looks like it could well be relevant and valuable and solve some of these kinds of security hazards we're seeing. We should do that, right? And so Zcash was the first investor, Naval and Polychain. They came in, and that was our seed round, and that was the launch of Agoric.
Right, and that was compared against the Ethereum smart contracts at the time
That's right.
in
That's
terms
right.
of
Yeah.
security and scalability and
Yeah. Yeah. Yeah.
all that.
Exactly. Yep.
That's
Yep. Yep.
that's very cool. So while we're on that, do you want to give a high level overview
Oh,
of
sure.
what Agoric is, what's his vision, mission, and what's the main problem that he's trying to solve in this space?
Yep. Yes, absolutely. So, I talked about smart contracts, right? Smart contracts enable strangers to cooperate, right? And to us, that leads to a more cooperative world. So the vision is millions of programmers building decentralized applications that billions of users use every day, right? Everyday use of this technology. We're a long way from that, all of us are, right? But that's the
Oh yeah,
vision.
100%.
That's why we've been doing smart contracts from, for literally decades, and shapes much of the technology that we bring to the table that was built before blockchain was ever around. Blockchain brings this replicated execution where machines in different jurisdictions controlled by different parties all come to agreement about what the smart contract did. And that lets us remove trusted intermediaries like eBay's, like StubHub's, like these people that are in a position to, rug, charge extreme prices, guide the transactions where they want, all these kinds of things. They aren't credibly neutral platforms. That is what you want for many kinds of broad scale cooperation. And so that's always been the driving vision. Agoric is a layer one built using Cosmos technology, in which we helped inspire, helped architect in various ways. But Agoric is a
Right.
layer one chain, where the core of it technically is you can build smart contracts in JavaScript with the familiar power of JavaScript, like async await and the real compositional value of being able to have other people build components that you can use in your smart contracts and so forth. And what we have found now, and where things are now lining up, is the platform is maturing just as the crypto market realizes it needs some things that turn out to be very unique to our platform. And this has led to this to orchestration. And I'd love to dive into that, but I'll sort of stop there and make sure you let you ask questions first.
That's fair. I mean, definitely we're going to get into orchestration because I think that is fascinating in and of itself. But I wanted to mention a couple of things regarding your work with Agoric, and you've said your work with Cosmos, because you said you've inspired
Mhm.
or worked with the Cosmos team. So I'm guessing that's the Interchain Foundation. Um, have you worked in an official capacity with them, as between like cross functional teams, or have you just contributed in open source projects, or you've shared protocols, or what was like the nature of your cooperation with Interchain?
Okay, so well, and it's more the community, but a little bit the Interchain Foundation. So what we didn't know when Agoric started out, and we were working actually with Polkadot because we got introduced to them through Polychain, and that too is in foundational infrastructure for fast finality. And our goal is, the actual consensus layer is kind of commodity, right? What you need is the fast finality and account model. But other than that, once you should be programming abstractly enough that that's not important, right? I want to, it's the level of I'm programming with TCP streams, and I don't care whether the network underneath Ethernet or Internet or Cisco or that's all packet delivery details, right? Okay, it's not quite that simple when you're doing blockchain stuff. Basic idea. So, but we, but there are various technical, struggles and issues with getting onto Polkadot, and then we ran into the Cosmos folk and found our people, right? Where
Right.
the key thing that the Cosmos community has is this underlying model of independent, sovereign. solutions to something connected with secure protocols able to cooperate with each other, right? In an open extensible system where, where there's no one that owns that, controls it, that sets all the rules and so forth. It's all peer to peer. And that's the way economies work. That's the way free societies work. That's the way we want software to work, right? And so that had strong alignment. What we didn't know is, you know, Zucky, Ethan, Jay, right? They kind of had that basic vision as they were building this stuff out, but they were struggling with how to do IBC. So we only found out this later, right? Like a year later. And Zucky stumbled upon one of the various websites that we all have created and added to. This one is sort of been the nucleus of the ongoing smart contract work in the '90s that we did, called eWrites.org, I think, where the E programming language, which was designed for doing smart contracts, Markham was Markham, our chief scientist, was the lead on. Was the main driver for, that talked about how do you do large scale distributed software and distributed commerce with multiple, sovereign independent agents in software trying to cooperate with each other. And this is all pre-blockchain, but from our perspective, a blockchain is just a machine made out of agreement, made out of consensus, and it can perfectly well talk to another machine using those secure protocols, or it can talk to a machine made out of silicon. So now you're talking to cloud services or my phone or whatever. But the model of how you do distributed, decentralized commerce fits, even if you're doing cross-chain stuff. So, Zucky had the
Yeah.
aha of this is the piece we were missing in how we think about IBC. He brought those two together and they married the ideas of how to do large-scale distributed commerce. And there's like a paper from 2013, I think it is, a distributed
Right.
electronic commerce or distributed electronic rights in JavaScript, which was how you do that in a model that influenced the IBC vision, as well as laid out here's what you need to do to JavaScript to make it suitable for smart contract programming. And Markham then went off into the JavaScript standards committee and drove those key elements into JavaScript so it could be a smart contract programming language, right? Which took taken 15 years, right? And Lucky and Jay, and they was like, this makes sense. We can do this low level, this initial version, and it's clear we know where to go. There's a resource to think about how it goes from there. Okay. So that was before we ever met them. Come 2019, Zucky and Sunny show up at our door going, so we've got this thing, we've got this vision of end software, and we've now launched. So let's talk about you guys building on that. So we walked through that. We walked through IBC. We showed them our, interchain protocol, and it had various elements that lined up. It's like, this looks interesting. We're having this conference in June, the Cosmos Conversations, I think it was. And we had a big powwow there of everyone involved in IBC and in Agoric communication protocol to kind of walk through to see the points of alignment from our requirements and their requirements and implementation of our. And it was just, straight up. It's like, this is okay. We're going to use IBC for our low level protocol, and we'll help you talk about how to do we'll bring all of our architectural thoughts and backgrounds and issues and stuff where, there's all things we've done before in other environments, right? From the Midori operating system at Microsoft to the Kaha project at Google to, all these things are, to the Liberty Alliance and Sun Microsystems project. So we've done large scale distributed communication protocol using this secure architecture before, tripped over many of the various issues that you're going to trip over: ordering, unordering, partially ordered messaging, 3-party. I mean, all these technical things we could dive into, right? And so we just had these continuing architecture conversations. So there was an IBC architecture committee. Chris Goes was the hero, just driving that forward at ICF. And we got a grant from ICF to help on the final definition and architecture of IBC and getting it out there, right? And there was a spec and a spec review process that took quite a while to nail down that thing, so you could have multiple working implementations of IBC. And that got it implemented, done. And then, Osmosis launched, and it really put a go-to-market on IBC, which was a huge, lift that really got that going. But before all that happened, all of the blockchains were islands. They were these independent, disconnected islands with, we'd talk about interop, and the ETH folk would say, no other blockchain will ever matter, right? And everyone else would say, yeah, someday we'll do interop. That'll be great. But right now we're, 5 years from now, maybe we'll care. Then IBC rolled out. It was clear you could do all this amazing stuff. 6 months later, oh, everyone was all about interop. Oh, we've been thinking about interop forever. We're interop first, all this sort of stuff. So now we've crossed yet another threshold into, we have succeeded at interop. We've succeeded at modular. We've got this giant sea of connected and growing number of independent chains and independent services. And we have succeeded at getting to the next challenge, which is right now you've got all these connections, but you've got to, hand carry your assets from one chain to the other, right? So if you've got USDC over on ETH, you've got to do a transition over to, Noble or via Axelar or something, and move it over to Osmosis, and then trade it, and then move that Celestia token over to Celestia and then stake it. It's just, 4 chains and 3 signatures, and it's just a nightmare, right? These simple things. And so we've got this, now we've created this opportunity space where now people realize they need these cross-chain applications, and that's sort of the next phase of evolution is that's where orchestration comes in.
Yeah, because I obviously Cosmos is fantastic, and I love Cosmos. And I was actually talking to the people at the Interchain Foundation, and
Yep, they're
I
great.
I liked it before we had a conversation, but after I had like a one-to-one discussion, I just started liking it so much more because I understand it. I have a much better
Yeah,
understanding of it,
yeah.
and it's fantastic. But I was going to say that the challenge is obviously you've got Cosmos, but then you have everything else that's not Cosmos. You've got Bitcoin, you have Solana, you have Ethereum, you have like independent ecosystems that are not connected natively to Cosmos, and they're not built to support the IBC protocol. So what's the solution there? Are we still looking at bridges, or are we looking to eventually come up with a more sophisticated solution than bridges?
Well, so first off, IBC is not Cosmos specific, right? It was designed to work with everything from proof of work chains, and things with different proof models and et cetera.
Right.
Now,
But it takes the core team to build the protocol in the chain itself.
that's right. It is more work than you would like to be able to bridge to those other chains. But people have built the bridge, IBC bridge, people built IBC Bridge to Polkadot chains. They have built various bridges. Sorry, not IBC Bridge. IBC implementation to Polkadot chain. So it's not Bridge. It's IBC. So it's each end is checking the light client instead of having to believe someone in the middle. We have the Axelar style of bridges to Ethereum and Gravity, where there's an intermediate chain that's doing the routing, but it is an actual chain. It's multiple machines run by different parties, all agreeing that indeed your packet moves. So it is much stronger than a typical multi-sig bridge from a quality point of view. And then we have like for example, Union now has an architecture that enhances IBC with stronger support for a richer set of light clients, and has the IBC full on end-to-end IBC to Ethereum. Right. So, as I said, IBC was an architecture that married this idea of independent chains able to, pairwise decide they want to talk, with the best practices around how you do that in crypto protocols with light client verification and that sort of thing. And so, it, and those ideas, some of them were in Cosmos, but some of them were outside of Cosmos, boiled together to make a solution here. So its target is to be TCP, not Cosmos network protocol, right? It's the and it's succeeding at that. There are other protocols as well. I mean, obviously you've got things like Wormhole, you've got things like Hyperlane and so forth. And, you know, just like the internet was not just TCP, it was a collection of network protocols that could all work uniformly across each other, right? With interoperability, right? It is perfectly fine if our crypto world is similar, where IBC is really, really powerful, really, really easy and straightforward to get connectivity out of. But if it's not on Solana yet, use Wormhole. That's fine. Right?
Right. Yeah.
And the nice
And
thing
that's
is you
fair.
want a layer that abstracts that away enough so that from the point of view of programming cross-chain application, yeah, whatever. It'll be, I mean, you want to separate concerns. I don't mean to dismiss the concerns of what are the counterparties and what are the risks of the protocols, because those are critical. They're just things you should separate from. Here's the core business logic I'm trying to engage in, of sell an NFT there, move the assets, and buy something over here, right? But I want to write that business logic and separately decide, okay, that's an acceptable bridge from a counterparty risk. Oh, that one I'm going to have to charge more for because of the risk, or that one I'm perfectly happy with, or, oh, that's going to be higher latency. I need to do some other thing, right? So you want to be able to have those concerns, but let them be separated out so that people can manage those and manage the risk. Don't have to entangle it all with the normal business logic.
Right, and that makes perfect sense. I think you would only need, as a user, you only need to be aware of what you're doing, maybe where you're transferring from and to, just to be aware of the gas fees or everything. But you shouldn't have to, like you pointed out, go through 3 or 4 or 5 hoops or more in order to get your funds somewhere else. I mean, to be fair, and we're kind of leading into the discussion about orchestration, you shouldn't have to think about 1,000 different chains and what you can do on each of them and what's the best solution, because you're just gonna paralyze. You're not gonna make a decision. There's so many choices. I keep thinking, right, for all the people that I know and all my friends that are not into crypto, that if I try to take any of them, and I don't mean get them into crypto as in go buy crypto, because that's easy, anyone can do that, go on exchange or go DeFi buy, right? But I actually to interact with the ecosystem or to understand how it works, it would take them years to just get there, to find their
Never going
ears
to happen.
around footing.
Yeah.
Yeah, never gonna happen.
My
But before we,
analogy.
I was just gonna ask you, continue your analogy, because I was gonna take you back to the 90s for a moment.
Oh, okay, okay. Well, my analogy is like, DoorDash or Uber Eats or one of these things, right?
Right.
It's like I push button, I order a hamburger. Do I care what cloud service that service is running on? Is it do I have to worry I can only talk to restaurants that run on Google instead of the ones that have their website on Amazon? It's like, no, right? I push button and a hamburger appears, right? That abstraction, we need to go even farther than what you're describing, where users want to be able to interact with these services in the same way that, it used to be a big deal. It's like, oh, you're cloud hosted. What does that mean? I don't know, right? Now it'll be your Web3. I don't care, right? I want to interact with a service that is now made possible by all this decentralization stuff, or buy an asset or invest in something. And I don't care about the underlying chain. I don't want to think about 1,000 entry points. I want to be able to use an application and go do it. And it happens to be, I'm buying a ticket for a concert and I have the ability to resell it. And the artist likes that because they get a portion of the royalties because it's all Web3 under the covers, or I can, buy a ticket and easily set up a raffle for some community or people to earn points, or, stuff that quickly moves into, under the covers, there's some DAO going on. I don't care, right? It just all achieves my goals that I have as a user, leveraging all of this awesome stuff that we can do with Web3. And that's what, that's the world that that mainstream users will come to. And that's a world in which you actually care about having millions of developers able to program this stuff. People talk about having millions of developers, they don't even envision what's the world like such that you need them, right? As opposed to, okay, we've got an AMM, we're kind of done.
Yeah. No, 100%. I feel exactly like you said. It should just be, this is Web3. Just go ham, go have fun, just do your thing. Like, don't think about all the problems that come, all the complexity, because you shouldn't have to know. Like, back to your example about burger, I shouldn't have to know, are they driving a scooter, are they on a bike, what kind of tires they're using for the scooter, or are their chains oiled? Like, I don't need to know any of that stuff. I
I
was
want
just
it to
gonna
work.
take you
I
back.
want assurances. Yeah. Go ahead.
Exactly. I just want it to work 100%. I just want to take you back to the 90s for a second, because you said that you were doing some important work into smart contracts back then.
Yes.
And I'm really curious to know what exactly you were doing and also kind of what you're involved in. But how do you define a smart contract, and what's not a smart contract? Because the way I understand it is that a smart contract is a piece of code somewhere on a machine or on several machines if it's decentralized network that I interact with, that I call a function on. How is that different than the rest of the internet, basically client server, and how that works?
So smart contract is, we have a clear definition that doesn't have anything to do with blockchain, right? Software that's enforcing the terms of a contract-like arrangement among third parties. So if it's a shopping site, there's not a third party, right? You're buying from me. That's still valuable, right? But it's also easy and obvious. Smart contract businesses are where the buy, I'm two-party market, or two-sided market. I'm the intermediary, and I'm enabling buyer and sellers to find each other and buy and sell to each other, and I'm enforcing the payment terms so they don't have to trust each other. They just have to trust me in order to engage in a transaction that previously required them to know and trust each other. Right? This idea of being able to offload, I don't like using the word trust very much, but offload reliance, where they're relying on the smart contract in the middle to make the opportunity possible, to make the cooperation possible. And so that's, and the important thing about that kind of that characterization is it really helps cut through the hype, both negative and positive, around blockchains or smart contracts, right? If you're not enabling third parties to cooperate, it's just hosted software. That's great, but there's no management of trust, and and enabling two-sided markets. It's not complicated. It doesn't, and from my perspective, it doesn't substantially enable more cooperation in the world, right? It doesn't enable someone I've never met in a country I might not know where that sends on the globe from buying something from me in a way that is useful, right? And that's where this new technology stack enables this to happen. It doesn't require blockchain. It requires something you can rely on in the middle, which without blockchain means it's someone operating some software on your behalf, and you have to rely on them doing so. With
Right.
blockchain, you have the opportunity to just rely on the software without there being any agency able to compromise its execution. So what blockchain brings is the high integrity execution of these software executing in different jurisdictions and controlled by different people, which the decentralization is in order to make it so that no human organization or regime can compromise the integrity of that execution, can slide in secret transactions, or take the highest ones, or stuff like that. Obviously you can write bad software that allows rugging underneath, but done right, no one can be in a position, no one's in a position to rug. We don't think anyone's going to be able to rug Bitcoin anytime soon.
Yeah. I don't see that happening. Okay, so it's just a piece of code that enforces the rules between two parties, essentially, and that could be anything. Would that apply to the way Airbnb works? I think you're giving the example
Exactly.
before in Uber, right?
Exactly.
So
Exactly.
market
You'd
makers in a
imagine
way,
20
or just
years ago, you would never have imagined, having where even for kids, a stranger will show up at your house and they now know where you live. You're going to get into the back of their car and go to some location you've never heard of in the middle of the night. Right. And you don't know this guy, you may not speak the same language. Right. And if I described that to you 20 years ago, you would look at me like I was crazy. And now,
hundred
people
percent.
all the time.
Yeah, no, and that's incredible to see how technology matures, right? Because they're not like, and it's a very good point, because a lot of people think, oh, smart contracts, they were just invented in like 2014 when Ethereum became a thing, and or cryptography was brought on by cryptocurrency. Like, these are much older technologies that are kind of like, are pretty mature, and without the time it takes for people to experiment and mature, the technologies to mature, like crypto wouldn't be here. Like, if these were new technologies, we would be probably in 2008 now, where half of everything that's built is broken and can be exploited.
Right, right, right. I mean, Nick Szabo was, and we were at the Foresight Institute. Actually, there's a nanotechnology book up there. Foresight Institute. It was in Los Altos, and was a lot of hypertext and online business and early network stuff and cypherpunks and all sorts. Various things came through and had these conversations. So we would have in the back room lots of conversations about autonomous software, smart contracts, enforcing, enabling cooperation or enabling secure cooperation. What are the protocols we use? TLS has got these weaknesses, whatever it is, right? How do we do distributed secure object messaging? All those kinds of things, in the 80s and 90s. And so, lots and lots of thought and articulation, and, Szabo's paper, Mark's papers, all that sort of stuff about laying the groundwork for this. The work, you asked about the smart contract work in the 90s. So some of it was the understanding of software, internet software enables this new kind of cooperation, led to a lot, led to ideas that percolated out and shaped a new generation of businesses, right? These smart contract businesses, eBay and PayPal and so forth. But we specifically had a project at Sun Labs The name Agoric for our company, Agoric, is inspired by the Greek word agora. It was in the Agoric Open Systems papers that Mark published, our chief scientist published in 1986, I think. And for software agents creating and participating in markets in order to manage compute resources in a way that free of central control, that allowed multiple independent parties to be able to successfully cooperate in a competitive environment of public service or something like that.
Right.
And so we did a big project at Sun Labs because Sun was, growing its server, internet server footprint. So it was for how to use smart contracts and this notion of distributed property and that sort of stuff to manage ownership of resources, control of resources, and so forth. Like, there was a bidding agent that would bid for time on the satellite dish on the roof and then bid for high bandwidth network in order to be able to get both of them and deliver an educational program in high fidelity from Stanford. Or something like that, right? And it was competing with people that were doing, net news in the background as an underlying thing. People doing NFS in order to load big files to do compiles and all this sort of stuff. And so, managing those resources dynamically using microeconomics, right, using markets, and agents that were all participating in those markets. And a lot of the ideas of what kind of object frameworks you want to easily be able to create in software, new, interesting kinds of property, were developed and talked about and planned and thought about there. Mark Miller was a lead on that. I was a lead on that. Nick Zaba was there for a while. I mean, this is one of those things where there was a lot of thought from various people about how you do that. And so this was separate from I'm doing smart contract business. I'm doing a business that looks like a smart contract that is out there, which we also helped some with. This was about how do we do this software agents participating in this kind of software market. Those more directly shaped the software architecture of programming smart contracts in Agoric. A
Right.
lot of the ideas. Electronic rights transfer protocol was something that Markham wrote about in the 90s, inspired by this work for how do you, in an object-oriented programming language, Java, JavaScript, C Sharp, whatever, OCaml, whatever, how do you represent some set of rights that can include fungible rights like currency or non-fungible rights like NFTs or tickets or whatever. How do you make it so they're transferable so you can escrow them, that sort of stuff.
Yeah, that's fascinating. And you know what's really interesting that these discussions were going on in the 80s and 90s, but we still had AWS take over half the internet. Like the internet is not decentralized; it's very, very centralized. In spite of all these discussions that took place in the 90s, um,
But they
interesting point
use
there.
very decentralized techniques and technologies in order to, internally, in order to manage those things, right? Now that doesn't mean that they don't have, that's one of the things. You can make things more centralized at lots of different layers, right? So they use Raft and Paxos, and they have data centers that all have independent determiners, so that one person isn't able to change the software in multiple data centers. And then they roll out geo regions. When they do upgrades, they roll them out independently and do dynamic testing and automatic rollback and stuff that is very using a lot of decentralization technologies.
Right.
There's still some, VP who gets to sign off on it and could make some changes, but even there internally they've got a lot of checks and balances. I'm not saying that's that we don't want a more decentralized world. Absolutely we do, but it is relevant that a lot of the technologies necessary to make a robust large scale system like that are directly relevant on both sides to the decentralization technology.
Yeah. Well, they also have such a huge responsibility. Like, if it's just one company, of course, there are different departments that are in charge of different regions, and they work with, people or like Heroku or other services that kind of package AWS services, sell them back at a premium because they're easier to use. But they still like to have the responsibility of half of the internet's infrastructure in your hands as one company. It's pretty fucking crazy.
Yes, yes, yes,
And
yes.
it's great that we have blockchain and we have a way to create more decentralization, and it's also part of the work that you guys are doing, which I think is fantastic.
Absolutely,
And I
absolutely.
also wanted to say congratulations on hosting the chain abstraction day. I think that's a great name, and I love the word abstraction because that's kind of encapsulates the philosophy of moving away from all the wires and just having like a nice little packet
Yeah,
that you don't need to open that black box to understand it. If it works and is reliable, that's all there is. I also thought it was a great set of topics there, and I actually listened to your discussion on orchestration, and I looked into like the orchestration API a little bit. I thought now's probably a good time to jump into that if you like to kind of explain a little bit
absolutely.
about orchestration, and then we get into the details.
Sure. Yeah. So I'll, what people are calling chain abstraction, which I think is a key narrative for the next round of the crypto interchain, is the realization that users want to be able to use assets and services seamlessly independent of the underlying blockchain. So that's a user requirement. And to me, it's really important and valuable that the crypto community is understanding that that's important, because that's a key element to us getting solving mainstream users problems in a way that mainstream users will care.
Right.
That's implementing that is hard, right? So that's the vision of what we need. It doesn't help you implement it. It's just what we need, right? Orchestration is the developer side of that. It's what developers need in order to be able to build cross-chain applications where assets and value and scheduling and all these things move across these different services and different blockchains in order to provide a simple, seamless user interface, user interaction for the users. And so orchestration is how we will achieve these chain abstraction visions. There are other elements of what you want in chain abstraction vision that may be more specific and more particular, like single user identities or easily shared user identity, and credentialing and various other things. But the really hard challenge, as we observed in the growth of the internet, is seamlessly stitching together all these available services that are now connected, right? But bringing them together and wrangling those cats to deliver a simple service for a user is the hardest problem in some sense. Maybe the hardest problem is understanding the user in the first place, but that people know how to do that. The technical infra to be able to wrangle that asynchronous world is something that we have that is, lots of people are chewing on pieces of it. That's the piece that we've spent decades building approach and infrastructure for and deploying in various places. So it's an approach that we have a lot of unique technology advantage and a lot of unique value that has taken a long time to build. Let me tell you, it's hard, but
I bet it
it
is.
makes a huge difference.
Yeah, no, I bet it's a challenge. It must be a major challenge because of like all the interconnected aspects of it. It's crazy, but it's in a way it's exactly what this industry needs, and I see this over and over again. Like there's a lot of hype right now in this like abstraction. Like you'll notice that so many people in crypto now are mentioning the word abstraction.
Exactly. Yep. Mhm.
OKX have built a multi-chain wallet that it can help you manage your assets across I think 85 or 85 plus chains. Everyone's like super hype on abstraction, and I think that's why it's really important to have this kind of communication protocol. Well, is it a protocol? Am I referring to orchestration as a protocol? Is that technically correct?
No. Hang on, my audio just worked out. So orchestration is not a protocol. I mean, it is a. So first off, orchestration is the challenge, the developer challenge, right? Um, uh, for for doing for being able to herd these cats. It is an API for smart contracts running on Agoric. So Agoric support for orchestration is an API for smart contracts running on Agoric to be able to easily reach out and manage positions and activity and assets on both Agoric, of course, and other chains. Where some of the fundamental key elements, and I was showing sort of this core code snippet of something that's relatively impossible on other blockchains. But the key elements are, for example, multi-block contract actions, right? Anything you're going to do that's blockchain is necessarily more than one block. And yet the programming model on every other blockchain is here, do a computation that starts in a block and ends in the very same block, and then you're done. And if you can't fit it in there, then you got to do a lot of work to store some stuff out and hope someone will call you so you can proceed. Right. And that's just not how people build all the stuff that they build in the rest of the mainstream developer world. That's not how you build Node.js apps or Ruby apps or any of these things. Instead, I take an action, it's going to reach out to that chain and create an account. And only when that's done do I proceed to the next line of code. My blockchain is, of course, concurrently doing stuff for a lot of other people. But this particular flow of one line of code after another wants to, wait for that guy to create me an account. Okay, now transfer some money into that account. Now take that money, send it through that chain over to there, do a swap, convert it to there, stake it there, pull the liquid staking token over, build a vault. All of those are actions that take time, that take multiple blocks, that are on different chains. Being able to write that as simple straight line code in a normal async await fashion is something that no other platform can do, right? And that's sort of the powerful, programming engine on Agoric. There are other people that are working on orchestration kinds of things. What I refer to as, for example, off-chain orchestration. You see that in products like 42. You see it in products like Skip, right? Skip is one of the, Cosmos-based things. They don't have. It's not a chain. It is off-chain. You do this. Okay, you done. Okay, now you do that, and it's reaching out to these different chains from an off-chain service to do general orchestration, right? Orchestration is the next modular, right? It's what lots of people are going to need to do bits and pieces of. But being able to do orchestration on chain is the holy grail. That's what Agoric enables, because then you get all the benefits of the high integrity of execution, of credibly neutral platform that's going to engage in a strategy that it's going to implement because the code is deployed there, and enforcing the will of the people who, the governance body that controls that code. And so that's what we are delivering. And so it's an API, and that you program to in JavaScript. So it looks like just sort of normal JavaScript code running the way you would expect. When I first presented the basic idea at last year at Nebular, to us that was just like, well, of course that's how you want to program. We really had not internalized just how hard it was to do in other platforms. So people would come up after us, they're just like, wait, you actually have timers on chain? That's crazy, right? It's like, wait, you don't have timers? How do you do anything that wants to relate to the real world? Because that uses time. And so yeah, we have
Yeah.
timers, extensibility. I mean, all that sort of stuff.
So, because obviously that opens up to a lot of possibilities, a lot of things that you can do with this, with orchestration. A couple of things, and first one is why specifically JavaScript? I know you mentioned that was it your colleague? I think Mike, if I got his
Mark
name,
Mark
that
Miller.
Mark Miller, right? That kind of worked with the JavaScript Foundation to introduce these standards into the language. But why JavaScript in the first place? Why not, I don't know, Python or whatever, something else, C sharp?
Yeah, yeah. Well, so C# is awesome if you're running on that platforms that work it. At the Midori project at Microsoft, we built a version of C# that was actually securable called M#. It's turned into sort of system C#. And, okay. Um, Markham and I were the only two outsiders at Sun Labs when they decided on Java as the language that Sun Labs would proceed. So we're very much language wonks, right? It turns out, as an accident of history, and I've told the story a few times, but it's really interesting, right? That JavaScript, the language, got standardized at ECMA, right? JavaScript bindings into the browser got standardized at W3C. And if you've ever been involved in politics or committees, you have never seen a technical line for a user mode system mode separation that secure operating systems and operating systems require. You have never seen that defended as vigorously as committees will defend their turf. So, by God, there is this incredibly strong user mode system mode separation in the specification of JavaScript that is implemented by all standard JavaScript engines, right? Such that you could take JavaScript code, and if you do not give it the FS object, then it cannot open files, whether it's running in the browser or whether it's running in Node.js, right? If you can run it, all privileges to access the environment come from this global object. And if it does not include host, you cannot talk to host. If it is in a browser, there are two objects there, window and document. And if I can take and create a container and run JavaScript in that native engine where it does not have a global object that has window and document, then it cannot touch the browser. It cannot leak secrets. It cannot get to the network. It cannot do all these things because
Right.
all the authority comes from window and document. And so I can then make okay, I will give you access to this one little piece, that I will then render into the window here, but you can only talk to me and tell me what you want to render. Great. Now you can render in a piece of the screen, but you can't touch the window and document, so you cannot go and make your own requests for images or whatever, right? You've got to use exactly the services I provide. That turns
Right. Is
out to
that a
be
much better
really hard.
encapsulation than Python, right?
Exactly. And so it turns out to be really hard to do that well. We have done this secure model of computation from the programming languages we designed in the 80s. I designed the Joule programming language coming out of research at Xerox PARC.
Wow.
There was the Vulkan project at Xerox PARC. The E programming language was designed this way. The Kikos, Eros, Kyotos, secure operating systems were designed this way. That's where a lot of these ideas came from. That went into SEL4, which is the most secure operating system on the planet. The Cherry chip architecture. I mean, there's a security architecture here for doing this sort of stuff, and we've done it. Done it at the language level for Java, C Sharp, Tickle of all things, E language, and JavaScript. Of them all, JavaScript is the easiest to lock down because it had that strong separation, right? Because nothing you can express in the language can let you magically get to these weird, these privileged authorities. Whereas in Java, there are ways to mention a file, which implicitly gives you access to file access, which in normal language expression, and I can't separate it out easily and protect you from being able to do things you shouldn't ought to be able to do. And so you have to do taming, and it's a much much more complicated process that we have done in previous incarnations. In the 90s, there was Kaha was locked down JavaScript in the same ways that they had been locking down Java. Um, but as it turned out, at the same time, then working with the standards committee to get features in so you didn't have to do so much work. So come 2018, Markham had gotten into the standards the ability to, in a standard JavaScript, lock it down so that it didn't have the mutability, basically we talk about hardened JavaScript, and that's what we got, elements of hardened JavaScript into the standard so we could create this hardened JavaScript. It's just the JavaScript you thought you were programming in, rather than a JavaScript where some sneaky library came in and made console.write instead of, copy your password file, send it to another country, and then write, because it was able to access, arbitrary privileges or change what the top level libraries are. It's just like, no, let's, that's stuff that we don't expect normal programs to do. Yeah, let's just make it so they can't, which is what you expect.
Fair
So
enough.
JavaScript started out very malleable in order to be able to rapidly evolve in various things, but it has the things, and Markham got that into the language, and others, right, to be able to lock that down. So now JavaScript that I program in is this hardened thing that behaves the kind of way I want JavaScript to behave, right? And that's what we build in. And so it's, you can do anything you want in JavaScript, except cheat on mutating stuff away from what the standard says it should do, right? And also lets us do deterministic execution, which you require for blockchains, which again, hard to do, hard to guarantee in Python, hard to achieve in other languages. It's got the ability to take an arbitrary chunk of JavaScript from someone and execute it directly in a compartment and give it only access to, here's your account, here's your bank account. You can accumulate money and put it in there, and then you can spend it, but that's all you can do.
Right. That's a very good point. Yeah, I hadn't realized that, because I always thought that JavaScript is like one of these languages that, apart from Python, it's got like the lowest common denominator. Like people are so used to JavaScript, to coding in JavaScript, they use it for everything, right? So my first instinct is like, oh yeah, of course they went for JavaScript, because you can use JavaScript for everything. You can use
Yeah,
it for web development, you can use it for backend, you can use it for whatever you want to
That's
use
right.
it
That's
for.
right. So it was
Uh,
actually Doug Crockford, who's well known in JavaScript circles. Doug Crockford and Brendan Eich, was the creator of it. But Doug Crockford's the one who, we had worked with him on previous secure distributed system stuff, because he was one of the people that worked on early cyberspace, right, early in the 80s and 90s, right.
right.
And Lucasfilm Habitat was the first, cyberspace with avatars and stuff like that, right? And Chip Morningstar coined the term avatar, right? He worked at Agoric for a while, and is now working on the same technology stack over at MetaMask with us.
Wow,
And
that's
so
fantastic.
yeah, and so he was the one, I think, that pointed out to Markham that all this stuff that you've built into the E programming language, which was a programming language that was designed for enabling smart contracts and being able to build secure distributed smart contracts, all pre-blockchain. The language you've got there, it's a scripting-ish language with these nice encapsulation properties. You could reproduce that in JavaScript. We could get all the key features you need over into JavaScript. And I know JavaScript currently is this kind of clunky language, because this was, late 90s, right? Mid 90s. Um, but there's a standards committee, there's a process, and and what you're bringing to the table with this stuff is what JavaScript needs in order to be able to grow and succeed, right? Realize, I mean, JavaScript controls trillions of dollars every day through Bloomberg and Salesforce and various other key applications where their logic and extensibility is all done in JavaScript, right? And so that's all due to having been bringing those security properties in, and that and the care that, you know, that the JavaScript Standards Committee and Markham and Doug and, you know, Chip and Brendan and, you know, and all the others on that committee bring to the evolution of that language to keep security and lockdown and separation and all these things as key features of the language, so that it is possible to build large scale secure systems in JavaScript. And, you know, there are very few interesting JavaScript programs that aren't all much larger than the largest smart contract that's running on Ethereum, right? I mean, you know, these are, you know, these are significant systems that are all built and composable, you know, using modules and libraries and, you know, all this sort of stuff that people build in JavaScript.
Yeah, and that's very cool. Any plans to support strongly typed libraries, maybe TypeScript on top of JavaScript at any point?
So we already do. I mean, you can write in JavaScript. Our orchestration API is typed using, you know, using a TypeScript file, so that, you know, because, you know, it's funny, when we were raising money in, I don't know, 2018 or 2019, one of the investors said, "So what are you going to do about a development environment? Because there's all these people building Solidity development environments." Just like, well, you know, Microsoft spent $100 million building VS Code for us, so, you know, that's pretty good. Good enough.
It's
Yeah.
good enough.
It's the number
Yeah,
one
for sure.
development environment on the planet. It just works for us. You can put breakpoints, you know. Right. So the answer is, yes. It plays well with the tool set. It plays well with the programming model, and um, you know, to use JavaScript. And I don't remember what question you asked that I got off track on. Sorry.
I was just asking if you can use TypeScript.
Oh yes, and so it plays well with the type systems. It
Yeah.
plays well with typedoc and so forth. But it is important to note that TypeScript typing is not sound, right? It is not. It does not actually give you any safety properties in the program, unlike C Sharp
Okay.
or Rust or something like that, right? It is
Right.
documentation and advisory. It helps you do refactoring. It helps you do completion and stuff like that. But it can be fooled if you choose to do so. So it's, you know, so it's basically, this is very helpful, but consider everything is declared unsafe, right? And so that means that our internal system is built primarily using JavaScript, because that's what, you know, because TypeScript is, you know, unsound typing that is very helpful, right? Very valuable, you know, with a ill-defined transformation to then run code. And that means that there is a distance between what you wrote and what code gets run. You know, there have been security hazards in every system that has that, from Java, where, you know, what's running is Java bytecode, to EVM, right? I wrote Solidity, what's running is EVM bytecode, and people can code stuff there that I can't express in Solidity, and there have been bugs in that gap. Right.
Right.
And so the advantage of JavaScript is we're running JavaScript, right? There's no, you know, what you see, you know, the design, the intent, the architecture is what you see is what you get. There are some ways in which that's not quite true until there are a few more things in the standard, but it's sufficiently close that it's quite, you know, you know, again, you can step through this stuff in the debugger. When you add TypeScript, you know, then you can start to have what you see be slightly different, you know, close but not quite what you get. Plenty of
Right. Because
debugging
it
to see through that.
compiles. Right. It compiles down to JavaScript. So TypeScript compiles to JavaScript, and you're saying that the compiling process can mess things up sometimes.
We have seen attacks in crypto with people who cheese the compiler in order to insert a backdoor. So, you know, the less you're, the smaller your stack, the better. So it's really advantageous to be able to, for the core of your program, write it in JavaScript and know exactly what it's doing, and have it be something that you can easily understand, debug, and so forth.
Right.
Or,
That makes perfect sense.
or you can see the translation. You know, that's the nice thing about TypeScript. What is the JavaScript to this? It's like, oh, okay, that's what I wrote. I understand it.
Yeah. Okay, that makes sense. That's a good point. I didn't realize that TypeScript can introduce, security issues. I've always been like a proponent of TypeScript because if you work in a team, like if you use JavaScript as an individual developer, you can understand your code. You're totally fine, but you might take a break, come back 3 weeks later, look at your code again. It's like, my fucking god, what's this spaghetti? Like, I don't
That's right.
understand anything. I don't understand what I wrote, and it's my code that I wrote.
Right.
And especially when you work with teams of multiple people, like it's easier to scale code and to keep it more organized. But yeah, good point
Yeah.
regarding
Yeah.
security.
You,
I
you
haven't
really want,
considered that.
you know, TypeScript really lets you say, here's what I intend to pass here. You know, a type system says, here's the only thing you're allowed to pass here. But from a what did I mean when I wrote the code? Here's what I intend to pass here is usually good enough, right? And so it's hugely valuable. I'm not dissing
Yeah,
TypeScript
yeah.
at all. It's just when we think about what about smart contracts and correctness and stuff that's going to control a lot of money, you want to make sure you know exactly what your supply chain looks like. And one of the things we look at is here's the subset of TypeScript that could be statically typed, strongly typed, so that you could, if four things that you can statically tell are in the subset, know that things are exactly what they say they are, and they can only be these types. That's a useful thing to do going forward. That's something that I think won't really appear strongly in the TypeScript community for a couple of years. So
Right.
and it'll race with AIs, I think, that are just look at this stuff because lots of people are applying it to JavaScript. And one of the advantages is 17 million programmers. That's where you're going to put your attention in terms of tooling and formal analysis and stuff like that, right? So people are applying tools to be able to go, okay, here's the code. Are there any places where the types are being cheesed? You tell me.
Right. That's very good point. Yeah, 100%. I mean, a lot of I've integrated AI into my workflow as well. I feel like it helps me out for manual things like, hey, I want you to build me an interface for this class. Can you just go ahead and do that? And I don't have to worry about coding manual stuff like interfaces. Like just do it. It's easy.
Right, right,
90% of the time they get it right. If you ask for more complex stuff, oh man, I've been arguing with AIs for I've had days where all I did was argue with the AI instead of writing the code, and I'm just actually wondering if it increases my productivity or if it just did I save time by creating code, but it's like the wrong code, and then I spend hours trying to get the machine to fix it.
yeah, 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 yeah.
I feel
Yeah,
like
go ahead.
if you're like a junior developer and you're trying to get into developing and you're going to be like, oh, I'm just going to use ChatGPT and I'm going to just be the best like that's such a slippery slope because you could just learn the worst practices. Like it's the worst teacher if you don't know programming.
Right, right,
That's what I
right.
want to say. Yeah.
Mm-hmm, mm-hmm. So that's one of those that's one of those uh you know I we're rolling it out into our patterns of use for both coding and non-coding. Will be we look at, okay, can what can we preload that already understands our way of doing contracts. We have our infra has evolved over time and improved and made things easier, got better integration. And so there's some things that are like, here's the old way we were doing stuff, here's the new way. You want to be able to say, okay, you know, here's the new way. You figure out how to get the old way ones to be redone in the new way, right? Give me an example. And then I can, I've got existing tests that should be identical, but now stuff is coded a new way. I've got, pattern reviews. I got various things that it can really help with, but it's really nice for that kind of maintenance work where you understand what the transformation needs to be. And it's easy to verify that it did it, but man, you really don't want to do it. I used to, in the 88, 89, 90 time frame, we were working with Autodesk. This is at Xanadu, where we were working on hypertext. And this is where, the first smart contract stuff was a sister company called Amex. But there was a project at Autodesk doing what I referred to as artificial stupidity, which was, because at the time AI was not very powerful. But
Right.
there was like two projects that were really interesting. One was a protein folding thing called Hyperchem to be able to do, and they were working on it to be able to do nanotechnology, design protein structures that could fold into reliable particular structures, so you could build interesting physical, teeny little stuff, right? And a human watching this simulation of protein folding can see that it's just like, what, how about if we just move it like that? And then it settles quickly, right? And they can much more quickly get these things to fold by just doing judicious pulling. So Paul Baclace was the guy working on this. He applied AI to that to go, I can see that it's folding. Let me try speeding it up. And it turned out to add, to accelerate protein folding on a desktop computer for many cases by factors of 10,000. I mean, it was just crazy. He found
Oh
he
wow.
found bugs where it would fold so fast the thing would go into an infinite loop and crash because it was just not expecting to get to there's sort of these compute
Logarithmic
maximums.
exponential.
And so that was really powerful. The other was he applied it to coloring the borders of the windows on your desktop, right? So that you could easily see what was a coding window, what was an inspection window, where was your social windows, that sort of stuff, which is clearly you or I could do better at that. Or, filtering news messages to prioritize. Clearly, a person could do better at that than AIs could at the time. but it wasn't worth spending a person on that, right? It was something that you know, like it would be easy. It's just not worth your time. So have something that isn't as good as you at doing it, right? But it can do it for you, right? Well, now code is starting to be in some ways, it certainly fits that ilk well. But it's starting to get in some ways where it can do things better than that you would otherwise hire out, but now you can just sort of have something do it for you, and that's pretty cool.
Oh yeah, no, it is cool, and I'm sure that in maybe even a couple of years, like you could write small programs across multiple files with references and imports and all that, and it would just work. Yeah, it's
For sure.
fantastic.
I think it won't
So
even be
just
a few
going back
years.
to it wouldn't be a few years, right? There's actually a model that is very good at coding. That's mumuch better than GPT-3 GPT-4 that came out, I think, a couple of months ago. I don't remember the name. I'll need to look it up. But it scored the highest on all of the tests that they were giving. So it's really about such a huge industry, and it's moving incredibly quickly as well.
Hmm.
I wanted to get back to orchestration for a moment and just ask a couple of questions regarding, first of all, like who's the target audience for orchestration? Because obviously it's uh, you need to be a developer, but like, are you thinking individual developers? Are you thinking developer teams, foundations? Who's it mostly aimed at?
So it is targeted at two things. So you know, our eventual target is mainstream developers, right? JavaScript can reach millions of developers that otherwise, they're never going to succeed at Solidity. It's just, the architecture, the security hazards, just not it's not a place to innovate, right? Um, and so, but and we have people sort of kicking the tires around that, but the focus of orchestration lines up with what the market is seeing now, where chain abstraction is critical. People want to be able to build cross-chain applications, and so there are two main categories. There are folks where I'm building a cross-chain application. I want to be able to do portfolio management, or actually even the simple thing. I want to be able to push a button, take USDC on ETH, and buy and stake TIA, or push a button and have it redo my restaking for me automatically. Go, it's compounding half of my staking reward and taking the other half and building me up a Bitcoin position. Right. And I just want to, push, that's the offer I want. It's clearly multiple chain. This is not, oh, it's a Solana application. No, it's a Web3 application, and it uses, Cosmos, and it uses Bitcoin, and it uses something else. Right. That's the
Right,
application that my users want. I've got a community that wants that. I'm going to build that. Right. So that's a cross chain application developer that's solving a chain abstraction problem, if you will, right? The second is people who already have an asset, already have something that's valuable in this connected sea and this ever growing sea of blockchains that are created by interop, that are created by modular, right? Where the next, as I say, orchestration is the next step after modular, right? It lets you create applications in the world that modular created for us, right? So you've got
right,
this connected sea of services. I've already deployed one. I would like more people to be able to use it in an automated fashion for their cross chain uses. Or I would like in the delivery of my thing to be able to provide some service that someone else over there provided. I'm a liquid staking provider. I can do liquid staking on multiple chains. One of the things you end up doing once you've got this liquid staked asset is, yes, you're going to collect the staking rewards. That's great. But the whole point of the liquid staked asset is to then do something else with it. Right. Well, I'm a liquid staking
right,
provider. I'm not the yield provider. So that means I have to go and, explain to you how you now take that and put it into an LP position in the following way on Osmosis, or take it over to Astroport and do this thing, or loan that LP position out. I don't know if that makes sense, on Ume or something like that. Right. Or, take it to a perp, whatever it is. I have to send you to somebody else's application, and I have now lost you as a customer to someone else's service, and they're now in control of your experience. If I could, in
right,
my application for liquid staking, say, here's 5 options for what you now do with it, and you click here, and I can do the automation. I know exactly what I need to do to let you get a position in Osmosis with the staking token versus the primary token, or or do it half and half, or whatever it is. You click here, but now it's in a feature in my application that I'm delivering to you. I'm able to integrate these other services into the application I'm already delivering. And that one is huge, right? Every time we give this talk, every time we talk about it and show people this astonishingly little bit of code to do, for example, in Korea, I talked about, unstake my TIA because I've got stake TIA because I want to participate in the Stride airdrop, right? So I want to go and get liquid stake TIA, and then I want to do something with it, but now I participate in the Stride airdrop. Well, That turns out unstake is now 21 days later. I got to remember to pick this up and finish it. It's crazy that that's a process I have to do with 3 signatures spread over 21 days, right?
Right.
Instead, being able to push button now, Stride could give me an operation. If they deployed a contract on Agoric, push button now, it'll unstake my TIA. 21 days later, it'll give me stake TIA, right? Or they could say, for a small discount, we'll give you stake TIA right now, and then their code will unstake the TIA, take it over, sell it for stake TIA, and replenish their stores in order to do this for someone else. Straightforward to build as a smart contract, deployed on Agoric, reaching across the network using orchestration. And so I think that the enhancement of existing services, it means that people who've already deployed something don't need to adopt Agoric directly. They don't need to move all their work here, even though many times that may actually be a good thing. And there are people that look at that, right? But they can start to add functionality using the power of the Agoric programming model, the power of JavaScript, the power of multi-chain blocks and extensibility and timers and all those things that the development environment of Agoric brings, and combine that with really easy ways to do this asynchronous orchestration of activities on other chains, right? Real easy ways to manage interchain accounts, to be able to lock things up on other chains and stake and delegate and undelegate and liquid stake and all the whatever operations and services those chains provide.
Yeah, that's fascinating. How would you go about doing that? Would you deploy your code into a smart contract? Would you deploy it? It would be a smart contract. So
That's right.
for an off-chain application, they wouldn't be able to interact with the protocol in a way
Well,
without it.
right, right. I mean, they could perfectly well deploy a small smart contract that was going to relay the things that they wanted to do. That I mean, there's actually someone that's looking at doing exactly that, right? Because then as the services that are available increase, it's easy for them to then just sort of take advantage of it for things that are in flight. But mostly the power is being able to deploy the smart contract that's going to execute that function for you. But I expect applications that have some off-chain component and some on-chain component. We certainly expect that. If I'm a bidding agent, I may or may not. I may want to have something that's going to do dynamic bidding across liquidation auctions for interprotocol, for example, right? I should have my interprotocol, right? The
Very nice.
stablecoin built, in Agoric on this stack, where
It's a cross-chain stable. I mean, it's a Cosmos-wide stablecoin, isn't it? I thought
exactly.
that's really cool.
Yep, all built using collateral from other chains. The process of charging interest every day is timer service dot periodic every 24 hours. Do the following JavaScript function, and that JavaScript function says, you know, charge interest. Go through all the vaults, and no, it doesn't actually have to go through all the vaults. It just bumps the counter, and now it's done. Or bumps a thing now, and checks whether things need to liquidate. And then it's done. And it just small function. It fits in a it fits in a relatively small amount of code. That just gets run on a periodic timer.
That's super
Periodic
cool.
timer. Yes. I realize I'm talking
Um,
very fast because this stuff excites me. So
No, it's genuinely exciting. I love hearing it. It's fantastic, Dean. The reason I was asking if an off-chain application can interact or can easily deploy this contract and interact with orchestration is like I've been into trading for a while. I've been into algorithmic trading. I've actually helped co-found algorithmic trading crypto trading platform. Call it ACR. So, but people can interact only on it's mostly between exchanges, right? You can interact with Binance, deploy your bots on Binance or on KuCoin or on Kraken or whatever. But it seems like this is such a cool opportunity to kind of allow people to kind of go out there into Web3 and interact with that. So I was just kind of trying to think how our application, which is completely Web2, might be able to go out there and support these Web3 features.
exactly. Yeah, and it is one of those things where you can sit there and have something that is in a position to query on a periodic basis or get a notification when some price crosses the threshold, because we have price oracles on chain for the interprotocol, and and eventually there'll be other price oracles showing up just to be able to make these things available. But the JavaScript API model is when the price crosses this threshold, run this JavaScript function, right? So here's my function. Again, we're all about building a reactive system. So run this function. Oh, the price crosses that threshold. I want to now, undo that LP position, split it up in these two assets, and buy a liquid stake token, because that's the trigger I was waiting for, right? Or,
Right.
or okay, there's going to be liquidation soon. I can see the price falling. So let me gather my assets over here so I can move quickly. And that can all happen in the middle of the night because you've got a strategy that's on chain to do it. That it's just going to see, I can see from the list on chain of liquidations rather than an off chain thing. I can see that some things are getting close to liquidation. That means there'll be an auction in an hour. The auction triggered. Great. I will go acquire. I've got an hour to acquire assets to be able to buy these things out of liquidation and place a bet, or place a purchase, and then automatically take that and go and deploy it into LP pools on Osmosis or Astroport or wherever. Right?
That's very cool.
All doable as code, which you can then still control from off chain, or you can upload strategies. You can have users where they have their off chain strategy, and you're pulling out the things you want to be able to react quickly on chain without disclosing all the private data of here's all the places that the user would be willing to sell. It's just I'm now placing a sell order to go and do a particular sell, right? Stuff
Right.
like that.
But so basically, the user would need to own the contract that they deploy. We would like we as an application wouldn't own it. The user would create their
No, either
strategy.
way works. Yeah, either way works. Several of these things would be I've got a service contract that like if I've got a portfolio manager, it's not that the user would own their own portfolio contract. That it's like I don't, users at Robinhood don't own their own Robinhood thing, but you would have a contract that you deployed, like the vaults contract for interprotocol, right? There is a deployed contract. It's got a specific governance mechanism to be able to upgrade and do things. So, no one's in a position to rug it, right? And now clients can go and say, make me a vault. And then there is a vault instance inside of that smart contract that is owned and controlled, if you will. I mean, it's controlled by that user by issuing requests on the vault contract for their vault, right? Object oriented kind of model. I've got a reference to my vault and I can send it messages, or I can make offers to it. I can make offers to the vault contract to say, here's some money if you add it to my vault and give me, I'm paying down my debt, but I'm only going to pay down my debt if you give me back some of my collateral. That's my offer. The vault takes it, does the adjustment, gives you back your assets, and all protected by the elements of offer safety in our smart contract model. And so orchestration contracts can work the same way. I'm going to reach out. I make a request to make me a portfolio. Here's the assets I want to add to my portfolio. The portfolio manager is now reaching out and making me ICA accounts on all the various platforms that I have those assets that it wants to be able to trade for me. That portfolio is there's 1,000 portfolios for 1,000 different people controlled by all those people, but it's all implemented in the same smart contract. There are
Right.
some for which you
That's
would
super
snap
cool.
out a new instance for each user, but it's not that the user had to upload that. I might just go to a service contract that says, give me a new bidding strategy agent, and it will launch a new instance of the bidding strategy agent contract that I'm now going to use. That's higher overhead, will cost more. I don't know if there's scenarios where that'll be important. We don't know of any
Right.
yet.
Well, let's suppose there's more than just prices. Like, let's suppose like oracles can also provide you with indicators, or they can provide you with other financial data that you can act on, and that just massively opens up the kind of strategies that you could create. So
Exactly.
you might have, I guess, a situation where you want the user to deploy their own instance of it because it's such a custom request that maybe other users
Sure.
don't.
Yep.
Yeah.
Yeah, yeah. I mean, I would
That,
expect trading houses to deploy their own stuff to do their own strategies and upload their own strategies. I mean, the weirdest thing, and this is one where it's JavaScript. It's just a JavaScript engine. You could actually have a smart contract that says upload JavaScript here, and we'll run that strategy tomorrow. Right? So this is not, right? Okay, we're not really ready for that until the gas model is complete. There's still lots of engineering to happen, but architecturally, the system supports that, right? Here's a search strategy I want you to use, and run it, once a day. And here's the JavaScript code to run against the API. And you could have extensible contracts online. I mean, a lot of our infra enables contract upgrade, so governance can then upgrade a contract to be the new, version 2. Where the chosen governance is visible in the contract as to what source, what DAO, what group is authorized to upgrade a contract. And could you use that to say I'm the dictator for life, so I could rug pull you? Sure, but you could also use it to not say that. You could use it to say, there is an econ committee. The econ committee gets to decide these authorities, like what's the liquidation ratio for ST Atom on vaults in IST, and the build holders get to decide when to upgrade the contract, and you got to sell them on any upgrade, right? And now the econ committee, here's its exact limits of what it can do. Here's what the community can do.
right. That's super interesting. So, I was gonna go back to oracles for a moment. Do you know the main reason why we don't have more data coming through oracles, or am I just ignorant to scenarios where we do have that data, like
We
indicators,
do.
or you know?
Oh
Mm,
yeah. So I mean, lots of reasons. So people, it's easy to take data for granted, right? You got to make sure what's the risk, what's the sources, what does it mean. I mean, if you're going to make a decision to allocate assets based on how much rainfall there was at a particular geoposition, well, who are you trusting to measure that and give you that number? Right?
right.
Absolutely, it's something that people need. There are services that do that. They need to play ball and sign an attestation, and now it's clear that you are trusting that. And they're we've got a model that will support that. Chainlink has a model that will support that, but someone's got to do that work. Someone's got to pay for that work, and someone's got to maintain that work over time. One of the things you want is not just here's the technology of Oracle. That is not a solution to the Oracle problem. This is one of those things where the solution requires continuous monitoring. It requires a community that understands what is the risk that these numbers are correct. I mean, we saw oracles. I don't remember which smart contract it was on, which stable coin it was on. It was on Comdex or Kujira, one of those. Had an oracle where it had three price sources, and it was taking the mean, the average of right. So one of them went to zero because they screwed up. So suddenly every price is being reported as a third less than its actual value because they were just doing the wrong average, right? They should be taking the median so that if you lose one, you get, I mean, three is still not enough, but nonetheless, that's one of those things where the important thing around these sources, how do you ensure that they are correct and trustworthy over time? That's pretty challenging and expensive. There are a few Oracle networks that are credible there and others that are working to do that. Agoric does that, and the platform pays for it for the key assets that are used for interprotocol, and they're in a position to add a few more that are straightforward, like ETH price and stuff like that, and they'll incrementally add prices over time. But that's one of those things where it depends on demand. So if there's a price that people need to deploy something on chain, of course we're going to work with them to, and the Oracle providers will work with them in order to figure out what is an acceptable, robust source of pricing from multiple parties so that no one's in a position to game it. And how is it going to be monitored and all these kinds of things. So, prices take a community and Oracle information takes a community.
Right. Yeah,
I think
that's
we are
a very
close
good
to
point.
time here, by the way, which I could
Uh,
sit and talk for hours.
yeah, no, honestly, it's super exciting and super interesting for me. So that's why I keep asking questions and just like absorbing it all like a sponge. It's fascinating. I just have one more question if you still have time, because I'm really curious about like how does Agoric sustain itself as a business? Obviously, the orchestration is, from what I can gather on the website, is free and anyone can go and build and use it. So like, what's your guys business strategy?
So, I mean, right now we're in our technology is finally maturing to the point where people can build on it. We are in the build up a community of developers and deployed applications, right? Revenue from that is unimportant compared to growth, right? This is about having people build and be successful at their businesses on the platform. Calypsos and Crabbles and folks that are building interesting applications. So that's our number one priority. We have money we raised from token sales, token purchasers, that this was in the top of the last bull market. So we're we've got a lot to do to get the platform and grow it to the point where they're all happy again. But that's something that we're in the same boat. We're very much we this is huge technology. Everyone looks at it, so like this is really awesome. But now we're working to get it more recognized, get people to understand how important orchestration is and how important it is to the next run up. That will naturally lead to increased activity and economic growth on chain, to the extent that we make it easy to integrate IST and use IST. That will drive IST based TVL. The design of the ecosystem is such that our focus is about growing an economy until there's a significant economy, and that leads to general value growth across the board. And so that's sort of our focus. We will likely own and operate businesses that leverage this technology. We will have services for developers, but frankly, we could get nothing out of the orchestration except enabling a rich economy, and then we have strong comparative advantage to then as the entry point for not having to commit to a particular infra, but just being able to access and use assets and services across any of these different chains. Now we can deliver that to Web 2 audience because it's all accessible, programmable, understandable via JavaScript. That's a huge value in terms of future proofing their stepping and dipping their toe into Web 3 from Web 2 applications. And so, we think that orchestration, I mean, as I said, orchestration is a huge element in Web 2. It's invisible because it's successful, right? But, when I push that button, I don't know that there are 60 some odd or whatever it is services to enable a hamburger to be delivered to my doorstep, and I don't care. It's magic. It just works underneath, right? Just swiping a credit card in another country has an astonishing amount of engine going through with hedging and money transfers and Swift and and credit offsets and all this kind of stuff to make it so I can buy a hamburger with a credit card in another country, right? Online services the same way, crypto will be the same way, and orchestration is what gets you there. And so there are lots and lots of places to be able to provide additional services there that will drive significant revenue to that we believe would drive significant revenue to build holders and to Agoric itself. Those are not the same, but there's strong alignment. Agoric is certainly a non-trivial build holder. We care about build growth, build usage, build adoption, build revenue, etc. Just as a
That's fantastic.
thank
No,
you.
that's incredible, and thank you for this value packed conversation. I think there's a lot of really really great nuggets of information there, and I've learned a lot about Agoric, which is fantastic. I wish you guys in the ecosystem all the best, and I want to see the development and the community flourish. So I'll keep an eye out. I'll be there, kind of maybe even playing with your orchestration JavaScript, smart contracts. That's of interest to me. Do you?
Welcome.
I have
Step
been
into my
converted.
widely distributed parlor. Yes.
Only took 1 hour and 20 minutes. One of us. um, no, genuinely, I had a great time. Do you guys have anything you want to announce for the rest of the year? Any announcements you want to make? Anything you want to shout in terms of links or social media or anything like that?
Absolutely. Well, everyone should certainly check out agoric.com/orchestration and our Twitter at Agoric. We will be the API will be public in May. We will have a hackathon in summer, and with the deployment of the initial version of the API, and then there will be steady releases, enhancements of technology to bridge across to additional ecosystems, add additional functionality. Add. I mean, the power of JavaScript is being able to have components that add richer and richer capability that people are only dreaming of now, and it's easy to incorporate that. We've got a long list that people are excited to build. But orchestration API, come check it out. Plan on joining our hackathon that will kick off at Nebula in July.
Awesome. Where's the hackathon going to be?
So we will have virtual workshops. We will have workshops at various cities around the globe where we're starting to build up developer hubs, and the hackathon, I believe, will be virtual. So
Oh, sweet.
it is a multi-week, 30-day or 45-day hackathon where people can really sink their teeth in and do stuff. And there's some key projects that are quite excited about what they can build there. But we will have the hackathon. We will celebrate the results later on in the year, and then showcase the winners at the conferences and the chain abstraction days that we go and present at. So it'll be exciting.
Incredible. Yeah, it does sound exciting. Well, best of luck, and we'll speak soon. This was genuinely super interesting.
Excellent. Thank you so much for
Thank you,
having me,
Dean.
Andre. Bye bye.
Thank you. I had a great time. Bye, everybody.